Our problem motivation is Eleanor O'Rourke's game. Nell and others' work show that growth mindset interventions in the area of math has increased motivation and excitement about challenge. The interventions have also helped to close the gender achievement gap. We hope by applying similar interventions to CS, we will be able to achieve those same results. Increased motivation, excitement about challenge, and a decrease in the gender achievement gap. Our research questions for this quarter were research question 1, how can we develop an interface that supports students developing a growth mindset by providing useful feedback embedded within a student's code editing interface? Research question 2, will rewarding the growth mindset in computer science increase women's interest in computer science? In order to solve these research questions, we need to tackle 2 sub-challenges. Tech research question, how can we automatically detect user behaviors that signify effortful actions that are conducive to developing a growth mindset in introductory programming? We tried to answer this research question through our user study. However, we did not get conclusive results this quarter. We edited our research question to be, what are good coding practices? Our design research question is, how can we use detected signals of effortful actions to then provide feedback within the user interface that reward effective actions as in brain points? This quarter, we came up with more need-finding results. We found it was difficult to find consistent behaviors among growth and fixed mindset participants. This first study shows our results, and then if you look at the second study here, it also shows results, and the red results are contradictory to the first study, and the yellow results are consistent. So different studies gave us different results, and it was difficult to find consistent behaviors among growth and fixed mindset participants. We also observed users flailing during the study, indicating a need for a system that promotes the growth mindset.
During the middle of this quarter, we also worked a lot on our technology. We updated our Atom package to detect keystrokes, but we also wanted to give users feedback so that on some of the coding behaviors that they were exhibiting. Our keystroke package now detects when users comment code and gives them brain points in the bottom right corner. Another thing that our code can detect is if somebody is running their code too often. So, for example, I don't know if this is going to work.
No.
Okay.
We also added time limitations to ensure that users couldn't game the system.
The last thing that we wanted to detect was if users were writing test cases, and we wanted to give users brain points for writing those as well. And we detected that by checking if users were writing print statements, since we didn't think many people used the assert function in Python. We also conducted a user study in the first 2 weeks of April when we got back from spring break. And in this user study, we surveyed students from Sarah's 295 class and asked them to complete 3 coding challenges. Throughout the study, we recorded the face video and also a screen capture video of 7 different students. The screen recording video can be seen here, and we used this to backtrack our keystroke data and understand exactly what participants were doing. After watching all of the videos several times, we created a qualitatively coded list of times when participants were pausing, coding, Googling, and also commenting and writing test cases. We also recorded qualitative things like if users were showing frustration or if they were asking questions. We had them complete a survey at the beginning that indicates whether or not they had a fixed or growth mindset, and selected the students based on which mindset that they had, if it was conclusive based on our survey. After this study, we also conducted a study in class with DTR students. This was around the middle of the quarter, and we wanted to test our Atom package with a new built-in feedback in the form of pop-ups and points. We collected also more keystroke data sets just so that we had a larger data set since 7 participants wasn't very conclusive. However, as Grace mentioned earlier, we found a lot of conflicting data, and this was kind of a sign that we needed to switch our mindset and try a new approach. Instead of trying to find coding behaviors that would indicate a growth mindset, we decided to try to brainstorm and detect good coding practices, and in turn seeing if promoting these good coding practices would promote a growth mindset for a user using our interface.
So based on our findings that it was difficult to detect the growth mindset directly, we came up with a list of good coding practices that we found by reading research papers, including Nell's BrainPoints paper, and we also spoke with experts, including professors at Northwestern and experienced TAs who have worked with beginner programmers a lot in order to identify what practices they find were very effective in helping new students succeed in programming. And we hope to use this data to develop heuristics from user behavior that will allow us to detect the growth mindset. And so, as you can see, we have a list of the different coding practices, an example of an associated example, and then the research to back it up. Now, there are a couple of limitations to this, and since we're unable to detect the growth versus fixed mindset, we plan on rewarding good coding practices instead. However, good coding practices are not necessarily correlated with the growth mindset, but like in Nell's research with refraction, we can reward good coding practices from a growth mindset standpoint and analyze our results from there. So next quarter, we plan on editing our Atom package in order to reward good coding practices that we discovered. And we plan on running a study to test rewarding these good coding practices and its impact on the growth mindset.